All right, so this one's not cloud. I'm not presenting HPC cloud, but I'll talk about cloud a little bit later. So this one is, I put all the HPC terms, technologies like that I have to worry about before and after. Why after? Is like, I'm on a year mission on how to do analytics and machine learning, AI, on HPC systems. So my CTO, my directors, I asked me, hey, Thomas, what is the right architecture to do these kind of things on HPC? We did pretty well, so we look at it, we spin up a team, go ahead, take a look at it, and we see, wow, there's a lot more technologies that we need to worry about. So you see cloud in there, provisioning, MongoDB, those are the terms that HPC have basically would not have to worry about before, but now we have to worry about it, all of them. So you see the world is actually like, boom, it's like become much bigger. Okay, agenda. So I'm going to talk about the analytic workload on HPC. Of course, money first, right? ROI, I talk about investments, like deployment strategy, why we need orchestration tools, data impact, and the HPC readiness, and things like that. So let's go. Okay, it's not doing the right. Okay, how does analytic workload land on HPC system today? Have any one of you tried to bring analytic workload into HPC clusters? Anyone? Two? Okay, still a few. So first of all, we need to know why, what triggers to look into it. Like from the IDC predictions, there will be $430 billion in terms of productivity gain if you do it right. If you do analytic workload correctly, better than your peer. $430 billion. So if 1% is like 4.3 billion, it's a GE-funded R&D 2015. If we can do it right, then GE is already paid for. So we don't have to worry about it. Even 0.001% is at $43 million. You'll actually get yourself a great promotion with that. So that's the trigger for it. Okay, there you go. So how does analytic workload being deployed? How many of you work with a data scientist in your organization? One? Wow, okay. So it's not rare because there's only a few data scientists in any of the organizations. There are very small populations right now in organizations. You can hardly find them, retain them, and try to train one. So it's very hard. So basically, during the development cycle, there's only a very few, small number of people who knows what to do. They try to deploy everything by hand themselves. But think about the populations who needs analytics. Marketing people needs it, HR people needs it, everybody needs it. So at the end of the day, you need to deploy it to a much, much bigger population set. And they have their skill set is not as good as those data scientists. So what to do? We basically find out is the best thing to do is to provide them with a web GUI, and then for the analytic job submissions, try to make the learning zero. That's what Sam mentioned this morning. So but we need a lot of different things, right? We need a web GUI. We need to worry about the API, deployment services, service clients. There's a lot of them running in the HPC system. So you see, all this has not been done in HPC landscape before. So why orchestration, right? Every time people talk about analytics, they talk about orchestration. Basically, three things: automations, efficiency, data handling, and security. I want to focus on the data handling and security because there's a lot more data resources than your Parnassus, than your Lustre, than your NAS systems is holding. I'm going to talk about that later on, and security is another big problem. How to ingress data, how to egress data out. So that's why we need to look at the orchestration tools, basically to shield all the complexity from us, from users and from the system. Okay, wow, this one is, I look at Resources Manager versus orchestration tools. Some of you may disagree on me, in terms of the scalability, load balancing. Resource Manager, can Resource Manager do that? Yeah, maybe some of them. Yeah, can you allow auto-scaling? Resource management? Probably not. Enhanced automation? Sometimes, some of them. So that's why we want to bring orchestration tools into HPC system. That's our intent. And there's a lot of different tools in the market today. Swarm, Kubernetes, Mesos, Cloud Foundry, Diego. So all of them is available in the market. Which one will you pick? Anyone has a defined answer that can share with us? No? OK, sounds right. Because it's still a Wild West, a lot of developments over there, so it's very hard to get the right answer. All right, now I want to switch the focus into AI. It's the buzzword, right? Every CIO, every director today, they talk about machine learning, AI, deep learning. It's basically the hottest topics in the market today. So why we need to worry about that? OK, drive worldwide revenue, $47 billion, even more than analytics, right? So Intel alone just spent $67 million. Google, $400 million. IBM, $200 million in this market. And there's more and more money will flow into it. But anyone knows about the ROI for AI? Anyone has a defined number? I don't think so. It's a very interesting thing. If you, after my talk, if you want to discuss around this one, I'm really interested in to find the formula to say, hey, how each dollar you spend in AI, how much money you will get. It's interesting, right? Everybody just throw money into it. But anyway, people are doing it, so we need to do the same. So when I look at AI, right, the stack is heavy. Hardware, we need to worry about OS, language, driver. Well, CUDA, we got CUDNN, we got frameworks, we want algorithms. Every time I talk to different data scientists inside GE, they try to do something different. They have different combinations out of these selections, and it's just an example of it. So every layers can be different. So without any orchestration tools, without automations, how much time we need to spend in order to deploy the right thing for our data scientists to do? So it's very hard, right? The hand deployment is not there. So we need to make sure there's automations, there's orchestration tools for it. I look at some of the deployment models, right? The left-hand side is the manual deployment process. People can buy workstations, deploy their models on it. They can do cloud. They can do it on cloud, deploy their web services. But at the end, we want to get to the right-hand side, right? The automated process. But what do we need? We need to containerize those workloads. We need to have this CDCI pipeline ready for it. We need to find the data set for the regression test. We need to have different zones, geographic locations for it to deploy. And at the end of the day, we need a platform as a service and container as a service or orchestration for it. Now, this one is an interesting one. I look at what's the position of HPC system, right? You see the circle there. HPC system sits on the side. We got an edge system. But if you look at HPC system and the edge devices, those two together, training, inferencing, is a deep learning system, ecosystem by itself already. It's a nice one, but if you look at edge device and big data system together, it's actually analyzing big data problems in a scalable machines using algorithms. This one is exactly what AI needs to do. But don't forget, the big data system has to interact with the HPC system in order for the data scientists to develop their algorithms. So this one is a circle, it's a big ecosystem, so all together. You cannot ignore any piece of that. Right? You cannot just look at HPC system or look at edge or look at big data system by itself. Data, data, data. Everything is around data. I hate to tell you the HPC system is no longer the focus where your data is where you need to worry about. But don't forget, data is not just files. It's not just databases. How about brain waves? In these days, brain wave gesture, my movement, every company is trying to capture those things too, right? And IoT sensors, all the data comes from these areas has not been a good standard for us to how to capture, how to handle. But what's the impact to HPC, right? Legal. Now, all in sudden, we are bringing human data into the system. Are you ready to protect them? How about the regulations around it, right? Connections, access, real-time processing is a big one because a lot of real-time analytics we need the system that's real time. We cannot submit it. It's not a batch job system anymore. We cannot let the job sit in the queue for quite some time and then we worry about it. No, cannot. And uptime and availability, 24/7. I know a lot of us do 24/7 support on our HPC system, but do we have the help desk people to support our data scientists' need real time? Probably not. So there's a lot of work need to be done. Okay, I'm sorry. This was the ultimate data challenge, right? If you have a business problem, right? Think about it. If you are in the middle, the business guy want to have a data challenge, right? So what kind of data do I need? These are all the people that were asked. Do data exist? Where are they? Do I have permission for it? How do I bring the data together? And after that, after the work done, how do I store them and document my work and make my data searchable? So this is the ultimate challenge that we need to figure it out. So at the end is, are we ready? I bring up a lot of challenge, right? I bring up the orchestration tools. I bring up AI. I bring up the data challenge. I think the ultimate question is, are we ready for it? You guys hear me? OK, now it's back. OK, good. OK. All right, yes and no, maybe. I love to give my CIO and CTO that answer. Well, maybe we're ready. Yeah, yes and no. I don't know. OK. We don't have to worry about the yes, right? Because no one cares, right? We have big hunk computers. We have cloud as resources. We have the high bandwidth network. We have parallel file systems. Those are set. Let's not worry about it. What about no? Auto scaling. Can we auto scale workload in our system? No. Are we able to work with a load balancer and proxy? How many of you deal with proxy every day? I fight with proxy almost every day in the last year. It's a horrible thing that I can tell you. But once you figure it out, it's not that bad because you can just kick the node with all the settings and applications, you know what to do. So multi-tenancy support. Once we get to the data scientists into the game, all different businesses want to jump into the system. Multi-tenancy support is a problem. And lack of the multiple database and data source support. PaaS. Do you have a platform as a service for people to deploy systems? No, I don't think so. So metadata on data also is another piece that I think we're lacking. So maybe part is, yeah, we have enough bandwidth, but it's not necessarily able to connect to the outside world. So that's lots of things to do. So I look at the architecture. I myself basically handles the architecture and the system design inside GE. So this one is I look at the hardware and the software architecture changes for future. So these are the couple things I want to bring up. One is network bandwidth can never be enough. Although we have EDR network, we have 100 gig network with a 3-node. If you let me put enough NVMe in it, I can choke it already. Only 3-node, right? That's never have enough bandwidth. Latency. Network latency is actually bring you away from the data. So this one is one of the topics that we need to worry about So, but ultimately, what we need to do, we want to bring HPC systems as close to your data lake, to the data point, to your data source as close as you can, right? And how to predict AI workload. This one, I still don't have the answer. So, because just DeepMind, right? It used 1,000 CPU and almost 200 GPUs for the Go game. But how do you predict AI workload? It's very hard to go ask money if you don't know, hey, what exactly the problem you're trying to tackle and how big the system you need. I still don't have the answer for it at this point. So resources also is how to balance it between the batch workload, the classic CFD and FEA workload versus the real-time workload, because they all fight for priorities in the system. Okay. So this one is something I look at, right? If you look at the right-hand side, let's put Resources Manager on top of scheduler, and I build a infrastructure as a service and lay it on top of hardware. Is it a good thing? I look at it, it's yeah, no. We spend almost a month or two to look at it, the possibility, and get the team together. Find it is not necessarily the good answer because it's very hard to implement. After implement it, application is hard to leverage all the API. Orchestration has API, Resources Manager has an API, and the infrastructure as a service has an API as well. So which one you need to cater? Which one is your applications need to interact with? I think it's very hard to do it, right? And also hard to integrate with CDCI tools. The CDCI tools, we use Jenkins for it, and it works really well with normal orchestration tools like Kubernetes and also Mesos, but Resources Manager, no, it's not there yet. So, but if we bring in orchestration layer, I talk about the need of it, but actually there's some negative impact with the orchestration tools in the HPC systems. I want to highlight that. Job submissions, you need to bring more resources, bring in more parameters from the jobs into the orchestration layers in order for it to work effectively. So there's some extra things that we need to worry about. It's very hard to troubleshoot when there's a scheduler problem, right? Our users, the classic question is, how come my job did not run? How come I'm at the last of the priority? If you deploy this architecture, well, we need to worry about Resources Managers scheduling, and also the basic scheduling inside orchestration tools also that we need to worry about. So how do you troubleshoot them? It's very hard to do, right? And also, resources handling to provision from the infrastructure as a service layer to offer resources to orchestration, it takes time to do it. So that's not as fast as we like. So we talk about handles how many HPC jobs per minute or per hour. So it's actually will slow it down. It's actually not working to our favor. So then what's the potential new architecture look like? I look at a couple of the possibilities. I'm sorry that people at the back, you may have hard time seeing it. I'll try to explain it. This layer is the hardware. This one is the infrastructure as a service layer. Resources Manager and orchestrations, can we parallel them? Get it together. Well, it's a full function available, but that's two problems. One is we force a virtualization because of the infrastructure as a service layer. And also it's very hard to align. They both will fight for resources. So which one to give to, that's very hard to do, right? Then let's forget about orchestration layer, right? Can we do it with Resources Manager and infrastructure as a service layer? Well, it's easier to deploy, but we still don't have the function of the orchestration layer, so which is bad to some extent. And it's a very HPC job focus, but how about the analytic workload? We still have the problems that we didn't solve. Then we look at how about kick out Resources Manager? No, I won't do it, don't worry. just deploy orchestration layer and infrastructure as a service. This was a classic private cloud model. It's much easier to do, but it only offers a basic scheduling functions like for us, topology-based like scheduling, no, and traditional HPC workload will have very hard time to be deployed on it. So first of all, we need to Dockerize all the HPC workload and try to deploy it, and how to bring MPI jobs into the system. It's not an easy thing to do. Well, at the end, how about just orchestration tools only without deploying any of the infrastructure as a service layer? So it's a very simple stack. I like it a lot. Single API and a single scheduler. It's very interesting, and it's a very lightweight. It has a very high potential, but still, there's only the basic scheduling functions available there. And also, orchestration layer is not mature enough as a resources manager today to handle the HPC workload right now. So still, it's not the right thing. You may ask me, so Thomas, you bring up all this problem. Why? Well, I'm an HPC troublemaker, so I'm here to create problem. So this one is I want to bring up 3 concepts. One is a scheduler over scheduler. So this one is something that I want everyone to consider, to think about. Is we can have a scheduler just focus on the workload, and also workload distribution and a business outcome. The business outcome is an important one, to do that, because we never thought of which job will bring the most ROI to our business, right? We need to worry about that, and leave the other schedulers to do the heavy loading on the resources handling and also satisfy the workload demand. So it's a scheduler over scheduler concept. That's one. Can we have a standard API, right? If I go back to the original, to the architecture that I looked at before, there's a multiple API, but there's never a standard in the industry that we can all leverage, right? The Power API is already there, right? How come they can succeed, but we are still fighting with multiple API? Can we do something there? The last one, it's not grid. I'm not talking about grid HPC, right? No, but distributed HPC system. So this one is to deploy the full HPC stack around data source. So this one is to bring HPC system to wherever your data source is. So this one is, and also very important, with an on-demand strategy. So we basically lift the HPC up with the automation tools and get it deployed to cloud, to private cloud, to where your data source is. Something that we did with the between PBS and Docker integrations, we work with the Altera teams on it. This one is one of the work that we did in 2016. We let Swarm Manager. It's a Docker Swarm. Swarm will take care of all the container management. It will auto-scale the containers up and down, and then users just need to submit the containers need to the Swarm Manager, and it will interact with PBS Professional to auto-scale the Docker node on that. So this one is a very successful project that we did, and so leave the IT administrators just enjoying their coffee, so they don't have to worry about bring a node to it. Before that, if we tell the systems you only have 3 Swarm nodes, there's only 3 Swarm nodes. No matter how many containers you bring in, but now this one will give us a flexibility. If we need more Swarm nodes, the PBS Pro will handle it, and then when we don't need it, it will kick it back to the HPC system. So I'm here to call for actions. 2 things. I don't think I can handle it. I basically bring up all the problems the potential architecture. We need to fine tune it. We need to work together. So I want every one of you here to work with me, to work together on the new architecture design. I do not have the answer. I don't know if you have the answer, please let us know. And it's a very hard problem. I think it will be something beyond myself, beyond the GE team, beyond the Altera team to do it. So, but let's work together on this one. And also the integration work, it's like we need resources manager to not to get into a closed systems. We make it integratable to other technologies as much as possible. Just like the work that we did, like integrate with Docker, integrate with Mesosphere and Kubernetes. I think that will be the future. So if any one of you have interest in working to the next level architecture, please feel free to contact me. Feel free to contact Bill or Sam, any one of it in Altera. So I would love to work with every one of you. And I need your power, and I need your help. Thank you.
Time for a question or two. Oh, hungry people. Okay, then I'm going to ask you a question. I actually asked you in email anyway, but maybe you can help out, which is, so it seems like there might be a difference in the user base for the analytic and machine learning workloads than there is for the HPC workloads, or a different in how they get to the machines. Can you say something about how that is?
I actually looked at that. Like the question is around like a different age, different user groups. How would they interact with the HPC system and the analytic systems like differently? We actually have like internal meetings around it. And the answer is like, no, we don't see a lot of difference. So age group difference, they all want like, everyone basically want a web GUI and click, and be done, right? It's like, there's groups of like developers, they always want scripting environments. They will say, okay, web GUI is like, how can you do that? No way. So it's basically by job function and also by the what do they need to do around the system. I think that will be the how to distinguish like what tools that they need instead of like age. You see, age is like haven't been impact us like much, and the geographic locations I definitely know because we see like a lot of people basically ask for the same thing inside, at least inside the GE organizations. We see that. Yeah.
Okay, one more.
Not really a question, Thomas, but like I was telling you in the morning, since you mentioned Kubernetes, we sort of have a prototype of integrating the Kubernetes scheduler with PBS. For the benefit of everybody, we can sort of showcase that to you and others, and offline, and work on that together.
Okay. So I think I know it's a statement, like, but I want to bring it up is. I think we don't have to, we cannot limit ourselves to one or two scheduling tools. And as long as like the market drives us to something different, we need to react. I hate to tell you that I don't think we're reacting fast enough today. The integrations is not there fast enough for people to leverage it into production environment. So that we need to speed up on that. Right now, Docker Swarm, Docker Data Center, Kubernetes, and also Mesos. Just all these three, right? And it changes every year. If you are in the DockerCon, the new generations of Docker Data Center is totally different than what they sent out last year. So a lot of work is coming.
Okay, thank you again.